Like everyone in the world today, people who live on sailboats benefit greatly from internet access. Here on Whitetail, we've used a couple of different ways to get reliable internet access when we're away from marinas. The first one is to use a cellular wireless router. This is a product, ours is made by Kudi, and this takes a SIM card, connects itself to a cellular network and provides internet access over Wi-Fi, and that's a really useful tool. Another is to use Starlink, Elon Musk's famous Starlink constellation of satellites. We have a Starlink dish, and the system incorporates the dish and their own wireless router. The wireless router also provides power to the dish, and that's kind of the topic of this video, because the dish then requires 110 volts alternating current. There isn't a DC version of Starlink yet, so this means that we have DC power from our batteries. We have to send that to the inverter. The inverter then takes that electrical power and converts it to alternating current, which the Starlink Wi-Fi router then converts back to DC to power the dish. And this is kind of wasteful. Like a lot of people, we want to run it off DC. We are going to be using in this video a method from Noah Clark at starlinkhardware.com, the method that he calls the easy way. The hardware that we need comes from a Chinese company called Yaosheng. I'll be showing you that in a minute. And this is going to enable us to eliminate from the Starlink system Starlink's own Wi-Fi router, which accepts AC power and then provides DC power to the dish. Instead, we'll be able to provide DC power directly to the dish, and the dish will use our Kudi as a Wi-Fi wireless router. So it'll be a much more streamlined setup. One of the things that I like about the easy way from Noah is that the way it works is that we don't have to modify the Starlink system in any way, which means that at any time we can revert back to the way it is today, where it's powered by alternating current and it uses Starlink's own router instead of using our router. So it's not about you doing it this way. It's not really about converting to DC so much as it is about adding a DC option. We can use it with AC using Starlink's own router, or using DC, in which case we would use our router. So anyway, let's take a look at some of the kit that arrived. So this is the kit set up, ready for just a proof of concept test, make sure it all works. Here is the cellular router that we're going to be using as our Wi-Fi access point with Starlink. We already own that. That's going to be running off of a 12 volt to 12 volt DC adapter converter there. The reason for that is just to protect the Kudi from voltages that might not be entirely correct. This is going to provide a good steady 12 volts out. The parts that came from Yaosheng are these two, and they're very nicely made. I mean, like, very nicely milled metal parts. They feel great. They've got no rough edges, nice bevels. This one is the adapter from the proprietary Starlink connector to a regular power over Ethernet cable. So that obviates the requirement to snip this cord and crimp an Ethernet connector onto it. So that's nice. And then this box is the PoE injector itself, which takes in power here, sends out PoE to the Starlink dish this way, and then connects to the Kudi or whatever Wi-Fi router you want to use there, and then this cable just goes off and then into the Kudi back there. Our boat, like lots of boats, is a 12-volt boat. So powering the Yaosheng equipment, I've got a 12 to 48 volt step-up transformer. So I've got two transformers here, a 12 to 12 to protect the Kudi, and a 12 to 48 to power all the Yaosheng gear, which is powering the Starlink dish. So that's what all of that looks like. And for the sake of just this test today, I'm going to be powering the whole thing off of, the world's most advanced electrical connector type, the cigarette lighter. So that's how we'll be testing it. Just a quick word about this transformer that I bought to go from 12 volts to 48 volts. It's capable of providing 48 volts at 2 amps, so that's 96 watts. And as far as I can tell, peak power draw for Starlink is 86 watts. And it goes down after startup to something much lower. So this 2 amp 48 volt supply should be just fine, providing power to the Yaosheng PoE injector. And then I'm breadboarding right now, and I'm using these. I just love these Wago connectors. These are the best thing ever. I love these things. I love the fact that I can clearly see that the connection has been made in there. I love the fact that I can clip things in here and out fast and try them out and move things around and move my equipment around and reuse the connectors later on. These things are the best thing since sliced bread. Okay, the mighty cigarette lighter is on, the Kudi is on, the Yaosheng equipment is on, and lo and behold, we are talking to our Starlink dish. It seems happy. It says offline. That's because we're in port at the moment, so we've deactivated our account to save money. We don't need it where we currently are, but we're able to talk to it and it seems happy. So that's a result. My next step will be to take this ramshackle assemblage of equipment and install it somewhere with a nice switch panel, so that it's not just lying around like it is here. While we're on the subject, the whole point of this is to get away from using the inverter as much as possible for the electronic systems. And so I've got a 12 volt to 12 volt here for the Kudi, a 12 to 48 here to power the Starlink, which is what we've been showing you today. I also have a number of USB-C power delivery outlets that I'm installing around the boat, and they will go up to 60 watts if I can get them 24 volts. So I'll be using this adapter for that. So all told, there will be 3 of these style adapters that I will install together with a nice switch panel. And yeah, we'll be going over to charging cords like this. This is a nice USB-C power delivery charging cord for one of our laptops that doesn't have its own USB-C charging. So that's hopefully going to reduce the number of instances in which we need to turn on the inverter with the inefficiencies that it has. Anyway, I hope that was interesting. I might make a follow-up video showing the installation once it's done, but this gives you an idea of how it all works together.